Anyways, this continues in the geek spirit here. That's the title of the talk, and I actually changed it because a Windows version of PC Grids came out after I submitted the abstract. So instead of going to all the trouble, which would have taken 30 seconds to change the title, I just figured I'd leave it like it was. Now, a little history on the program. The original PC Grids was developed by a couple people, Ralph Peterson and Jacqueline Lord at the National Weather Service, and we're going way back into the 90s here. It was a DOS-based program, remained that way for a long time. And then this gentleman named Jeff Crabb came along. He's an electronics technician with Nestes. He works at Wallops Island, Virginia, where the big satellite station is. And he decided that he was going to take this on and revise and enhance PC Grids on his own time and give it to people at no cost. So how smart is he? But nonetheless, it took him a while to convince Ralph Peterson to give him the code, but once he finally got the code, then he started doing all sorts of cool stuff with it. A little bit of additional history. So now we have WINGRIDDS, which is the first Windows-based version of the program. And all of the development, as I mentioned, has been on his own time, and the cost of the program is free. Now, there are other options out there in terms of looking at model data, and I don't know if is Rob Dale here? Okay. He's has set up a really nice thing with his little company where you can get GARP and GEMPAC on a Linux box, and that's the system that a lot of universities use. You can do a lot of complex stuff with that. But if you just want to download something at home and you don't have a Linux box, then that makes it a little bit tough. So this is something you can do on any Windows machine. So where to get it? You go to www.winweather.org. And I'm sure I can, I don't know, by the end of the conference, type something up. If you want a list of these links or whatever, you can have them all in one spot. All the installation files are there, a 183-page user's manual. You can make this as simple or as complicated as you want. I don't want you to think that this is like just a overwhelming program. If you only want to do basic stuff with it, you can do that. If you really want to go nuts, you can do that too. He just added recently some high-resolution world maps, including counties and rivers, which is sort of nice. And then, those of you, anybody in here use Digital Atmosphere? Okay. You might recognize that web address as being the site where you get that, but there's also a number of forums on there, and one of the forums is PC Grids, and there's an awful lot of people that use the program that post ideas and different things that they've done with the program, so I would highly recommend, if you decide to use this, to go to that site and check the forum. So how to get the data? You have to download what are called grid files, gridded binary files from the FTP servers, and the National Weather Service and NSET both have them. These are some of the FTP sites. I won't actually read them out here. We'll just sort of list them one by one. And the file names and the sizes vary according to the resolution of the output, the number of model levels, and the number of variables that you're looking at. Now, you probably have heard that the NAM WRF is running at a 12-kilometer resolution, but if you downloaded the files that actually have 12-kilometer resolution output, these are monster files. They're huge. So you can get output at lower resolutions, 40 kilometers, 80 kilometers. I once had a good friend and a coworker years ago that when I said, "Oh, I heard they're increasing the resolution of this model," and his response was, "Great, now we can have more detailed errors." Okay, so being able to look at a tremendous amount of detail 180 hours out into the future with the GFS is not necessarily an advantage. A little bit more on how to get the data. So if you have a lot of bandwidth available to you, if you have high-speed internet, I mean, not the imitation stuff I'm seeing at this hotel, but the real thing, then you're it's going to be easier for you to grab a lot of these big files. If you don't, it's going to make it tough. They come out every 3 hours for the GFS, so instead of going every 3 hours, maybe you could have a 6-hour interval or even a 12-hour interval, and that would obviously cut down on the amount of stuff that you had to download. But there is another very cool option. How many people in here are familiar with the Nomad site? Okay, cool. So it's new for a lot of folks. This is a site, and there are actually, I think, 2 or 3 of them, but this is the one I go to. www.nomad5.ncep.noaa.gov. You can go in there and you can pick the model you want to look at. You can pick the runtime. You can pick only the variables that you want. You can pick only the forecast hours that you want to see. And best of all, you can define a geographical area that you want the output for, and that greatly reduces the file size. Like, for instance, if all I want to do is look at the southeast because I'm in Raleigh, why should I download the global GFS for Spain and Africa and Australia and all that? So the data requested, once you fill out, and I'll show you what this form looks like, is placed in a temporary folder which you can then access via your favorite FTP program. And you have a choice. You can put it in a folder that only survives for an hour, or one that only survives for 3 hours. But it tells you what the address is. It makes a unique FTP address for you to go to. And if you do the 1 hour one, you have 1 hour to go to that site and download the data. Now, this is what it looks like once you go into the Nomad site, and I know it's sort of hard to read, especially if it's in the back, so what I'm going to do is take that area in the rectangle and blow it up. So supposing I wanted to do the GFS half a degree by half a degree resolution, which is the highest available that I know of, I would go over there and click on FTP2U, okay? And then I would get a list like this of all the files available for that given date. So again, I'll blow up that little rectangle. Look at the size of these files. That you're talking like the 105, the forecast hour 105 there, the middle one down, 198 megs. So you can imagine if you downloaded every 3 hours out to 180, how long that would take. You might get it done by a change of season, something like that. So you go in there and you pick the forecast hours you want to look at, and then you go to this page called a grid filter, and you pick only the variables that you want. Now, I'm cutting off the right-hand side of this because I couldn't fit it all on one screen. If you want to do all, you can do all. But if you only want 1,000 millibars, 850, 500, 250, maybe the 2-meter temp, the 10-meter wind, that's all you got to get. Select the variables desired. And some of these may look a little strange, but over toward the right, the second line down, you can see HGT for height, TMP for temp, PRES for pressure over there toward the left, vertical velocity. So you, again, just pick the ones you want to pick. And then this is the killer, the good killer. Down here, you define a subregion by longitude and latitude. And again, by doing that, it's like you're doing a little cookie cutter. You're taking out just a part of this big, big file so that it's not so cumbersome to download. And then finally, you save results on their server, and you decide if you want the 1 hour, 3 hour option. You hit start download. You'll see these files being downloaded to a specific directory on this server. And then once it's done, it'll tell you exactly where to go. And I guess you can do this on a web browser, too. I mean, you could put an HTTP address and download the files that you wanted that way, too, if you don't have an FTP program. So now what do you do with the data once you download it? Well, all of it has to be downloaded into the WINGRIDDS /grid/NWS directory, which when you download the program and set it up, all those directories will be created for you. And then you run the data processor within the program that changes the data into a format that WINGRIDDS can understand. And again, this is going to be really tough to see, but this is the way the program looks. You go up to the File menu, and it says Convert Grid Data, and then Convert Regular Grid Data. And then this screen will appear, and you'll see these numbers flying by as it changes each one of these variables and so forth into a format that PC Grids can understand. So now it's time to actually look at the data. Now, there are two ways you can do it. There's a menu-driven option. I think the thing comes with something like 2,000 macros already in it with every conceivable thing you'd ever want to look at, but it's all previously defined. You don't have any control, over the contour interval or anything else. So if you want to really be a geek, like I am, and have complete control, then you do the command line option. And that gives you total flexibility to create plots any way you so desire. And again, there are a whole bunch of macros that come with the system. And creating new ones is actually pretty easy. Once you learn the language on this program, it's not bad at all. You open up Notepad, okay? Nothing complex there. So let's create a macro which displays sea level pressure with a contour interval of 2 millibars, and we're going to overlay or underlay the 1,850 thickness with a contour interval of 10 meters. And we'll also animate the data through all the various times. So this is all there is to it. You type in ANMA for animate macro. You type in loop, and then just about everything in PC Grids is 4 characters long. So you have pressure, MSL, mean sea level, contour interval 2, and then you put an ampersand in there because you're going to overlay another variable. Height, HGHT, layer difference, LDIF. What is the thickness? Okay, it's the difference between the height of one layer and the height of another. You set your layer at 1,850. Your contour interval is 10 meters. You end the loop, and unfortunately, I can't run the program live to show you what the end result of that is, but what you would get is a plot of the sea level pressure and the 1,850 thickness automatically looping through all of the hours of the model. You can also, with this new version up at the top there, he's added some keys where you can open up 3 or 4 or 5 different forecast files, like maybe the 12Z run yesterday, the 0Z run last night, the 12Z run today, and go back and forth. And maybe if you want to compare how the last 3 runs have all verified at the same time. So you start off with the first run, and you say hour 72, I want to look at this. Then you say, okay, let's go to the next run and look at hour 60, okay, which would verify at the same time. Then go to the next run and go to hour 48, okay, and then overlay all these on top of each other. So this is Saturday morning's GFS showing where the zero line at 850 was forecast to be in 72 hours. Then that was the GFS forecast for the zero line at 850 from the next run, 60 hours out. And this was from the run yesterday morning, showing where it was going to be in 48 hours. So you can see a clear trend there, that it was shifting that zero line farther and farther to the south and east every run. You can do wind plots at any level you want and overlay different levels. This, I believe, was the 10-meter forecast wind at a given time. And then I added the 700 millibar winds, so you can see how the winds are changing with height. Can you all tell here that there's a wind shift line right in the middle of Texas? So instead of just looking at it that way, what I did was I typed in a very simple command, DVRG space wind, divergence of the wind. And so you can see how strong the convergence is along that boundary. You can do isentropic analysis. How many times have you read in your area forecast discussions that the I-295 isentrope, there's, ascent going on later on tonight? Well, it's real easy to do that. You type in I-295, not the highway, but the isentropic level, and then you plot pressure. And so there are your pressure levels, and see how they're all packed there right near where the front is? Then you overlay the wind at that isentropic level, and you can see how the air is ascending. It's actually going from about 940 millibars up to about 800 and, what is that? Can't even read it. About 850, 840. And so you can look at that and see where the areas of ascent are, which is a real easy thing to do. And this is my last slide. This is a brand new feature which is not available yet, but it will be within a couple of months. And finally, the capability has been added to make use of Windows 16 million colors to set up color palettes so that it doesn't look like a program from the 1970s, okay? I just put this together real quickly last night. This is the 500 millibar height pattern. You can graduate it. You can have it so that it ramps as opposed to having individual colors for each height. But finally, that capability is coming. And Jeff's also going to be working on ways to import current data into the program so that you can actually plot, do a surface plot and do different types of analyses with that data. All sorts of different things that he's working on. It's just phenomenal what he's done, again, on his own time, but with no revenue coming in at all. So that's the last slide, and I don't know if we have time for any questions, but any questions, comments, death threats, whatever? Yes? There is actually a program within this WINGRIDDS which will do that, but he has it all set up to get the biggest files. And so I spent way too much time on this, but I downloaded an FTP program a couple of weeks ago and tried to learn how to write a script. and it reminded me of how much I stunk in college in computer programming. But even if you could get somebody to help you do that, you could write a script that would say, only get these files. You could even schedule the script to run at certain times so that when you came into work, it would just be there. Yes? Oh, really? I've only tried this program at home, the FTP part. You're right. But we do have a staff that has, an IT staff, which has written some stuff for me before, which has been very helpful. And like, for instance, we download model files every day from this group that's running this model for us locally. And instead of opening up the firewall so it comes straight to us, he downloads it to where he is, and then he FTPs it from his machine to ours and adds a little bit of level of security there. So what I may end up doing is going to him and say, help, you know, help me set this up. Yes. Yes, but they're very, the Canadian and the I think the Canadian is pretty detailed, and maybe even the no-gaps as well, but boy, the folks with the European, they're stingy. You get like 500 millibar height, sea level pressure, I think 850 UNV winds, and that's it. And you pay dearly to get anything more than that. One of the things that Jeff is working on is that, I don't know how many of you know this, but all these models from different countries and so forth, they're on different native grids. And so if you wanted to overlay like the European 500 height with the GFS 500 height, you can't do it because they use different map projections. So what he wants to do is set up a program where it would remap all of that to the same projections, so you could do genuine comparisons of these different models, which would be pretty cool. Yes? Oh, gosh. I mean, some of these websites update pretty quickly now. But, you know, usually when you look at these FTP servers, I mean, they're posting that stuff literally as each hour completes. And so it's fairly quick. And, of course, the thing I like about it is that, I mean, there are a lot of neat sites out there to look at for model output, and they're getting better and better. But there's still maybe one or two things that I want to look at in just the way that I want to look at it. And nobody offers that, and so it's the whole control freak thing, you know. Anything else? All right, thank you very much.